Alright, as we look at section 2A, we're going to go through number 1, 5, and 7. A few different examples of how to graph a line. Now this might be hopefully a topic that you're familiar with. If you think back to algebra, doing some standard graphing, we have our XY coordinate plane, and what we're looking for when something is in this form where we're solved for y, we think of that as our y equals mx plus b form. And in that form, the b is the y-intercept. And the y-intercept means where does it cross the y-axis. So where does it cross that line? In this case, it crosses at 4. Then the other piece that we look for is our slope. And our slope tells us how fast we are going up, what rate of change we have going up. So if we mark this, we go up 4, and that's where we have our y-intercept. That's where our line will intersect the y-axis. The 4 right here is referring to the slope. So what that says is rise over run, y over x. That is a steep slope, 4 over 1. So we're going to go over 1, and we're going to go up 4 more. Give us our next coordinate up here. And now when you're graphing a line, once you have 2 points, that's enough. You could graph more points if you're, let's say, not very good at drawing straight lines, but generally you can get yourself into trouble by drawing too many points, so you're better off just drawing 2 and then tracing a straight line to the best of your ability. You can see here that was a little bit off, but that one came out a little bit better. So you're going to trace a straight line through that. Number 5, we're going to skip all the way down to that. Some of those other ones up there follow the same basic mold, but on number 5 we are told that we have an x-intercept and a y-intercept. These problems, even though they look hard, are actually quite simple because it tells you where it crosses the y-axis and where it crosses the x-axis. In this case, the x-intercept is -2, which means you go back 2 on the x-axis, and there you have one of your 2 points. The y-intercept is 1, so you go up 1, and there you have one of your 2 points. Now, because you have 2 points, you can go ahead and trace yourself a line. So there we go. So we drew our line. We have our 2 points and we draw our line. So that's all you have to do when you're given the intercepts. And then finally on number 7 down here, this form is not giving us intercepts and it's not in that y equals mx plus b form. There's 2 ways to solve it. You can choose which one you're more comfortable with. One way is to get y alone so that it is in y-intercept form. So if we did that route, we would have to subtract 4x from both sides. We get -3y equals, and I'm going to put it with the x part first because I can redo the order of addition. So -4x plus a -12. And I would then divide every single term by -3. So in this case I get y equals +4/3, the negatives cancel, x. And you'll notice I put the x out front just because it helps me better see that my slope is 4/3. And then -12 divided by -3 is a +4, so +4. So I could get it in that format, and then I could trace my line. My y-intercept here is 4. My slope is a rise of 4 over a run of 3, heading up into the right. So it's going to go in this direction. Before I actually graph it, the other approach that you might find easier is to get yourself some intercepts. So if you plug in 0 for one of the coordinates, you will get the other intercept. So if I plug in 0 for x, this term goes away. Now if I solve this equation, -3y equals -12, divide both sides by -3, and I'm going to get y is equal to +4. That y is really the y-intercept. I can do the same thing with my plugging in a 0 for y. So if I plug in a 0 for y, this term will go away, and I get 4x equals -12. Divide both sides by 4, and my x-intercept is -12 divided by 4, which is -3. So there's 2 ways to go about it. You can see that the y-intercept is 4 on both of these. On this one I have the slope, which is a different piece of information than the y-intercept. That's why those numbers are not the same, is because it's a different information. If I'm going to create my graph over here, let's try it this way. If I did my y-intercept of 4, and then I had a slope of, for every 3 I go over, I go up 4. I could go the reverse direction as well. I could go down 4 and left 3, because my slope here is still going up. It's still positive. So that would be the 4/3 slope. You can see, where do I cross the x-axis? -3. So it doesn't matter what approach you take with these types of problems. As long as you show your work, you can either solve for y, do it more traditionally, or plug in 0 and get the x and y intercepts.